Hello, everybody. Welcome to my lecture 4 for my Math 241 trigonometry with factors. Now, today we'll cover two sections, 3.1 and 3.2. 3.1 is on section 3.1 is on reference angle. Reference angle. Now, let's start with some definition. What is a reference angle? Definition. The reference angle or angle theta denoted by theta hat. So it's the same notation, right? Theta, this is theta. But for the reference angle of theta, we use this hat here. Okay? The reference angle theta hat is the acute angle formed by x-axis and the terminal side. With vertex at origin. Okay, now notice that the x-axis here does not have to be positive x-axis. Doesn't have to be positive x-axis like angle in standard position. Angle in standard position has to be positive x-axis, right? Now, reference angle doesn't have to be. Now, let's take a look. Suppose for example, we have this is the rectangular coordinate system, and let's say this is a terminal side, right? Let's say this is a terminal side. So this is the angle theta, right, in standard position. Now, the reference angle is the angle formed from positive x-axis to that terminal side. And it has to be an acute angle. Okay, at most 90 degrees to be more precise. Okay, for example, in this situation, if the theta is in quadrant 2, right, the angle is in quadrant 2, then the reference angle, as you see, the reference angle for this theta in quadrant 2, the reference angle is this acute angle here. Okay. Oh, of course, if the angle is in quadrant 1, if theta is, sorry, if theta is in quadrant 1, if theta is in quadrant 1, then let's say this is theta here. Okay. Then the reference angle will be the same to that theta. Okay, because it's already an acute angle, right? It's already an acute angle from x-axis. Okay, if theta is in quadrant 2, like the picture I showed you earlier, then the reference angle is from negative x-axis to the terminal side. Okay, now let's go on. Suppose the angle is in quadrant 3. Suppose theta is in quadrant 3. Suppose theta is in quadrant 3, say here, right? So this is the angle theta. Oops. This is the angle theta, right? Theta is in quadrant 3. Now notice that the acute angle from x-axis will be this one here. This is the reference angle. Okay. What happens if the angle is in quadrant 4? Let's say we have this angle here. Okay. Then theta will be this. Let's say this is the angle theta, right? Then the reference angle will be this one here. This is the theta head. Okay. Now, suppose, for example, let's do some example. Suppose, for example, we have theta is 30 degrees. So what is the reference angle? Well, because this theta is already in quadrant 1, because it's already in quadrant 1, right? Let's sketch that. 30 degrees in center positions here, right? Okay. It's already in quadrant 1, so the reference angle will be the same to that angle. Okay, so the reference angle will be 30 degrees also. Okay. What happens if theta is in 135 degrees? Theta is 135 degrees. Notice that this is in quadrant 2, right? 135 degrees here. This is 135 degrees. And the reference angle must be this one here, right? Must be that one. Okay. Now notice that 135 degrees and the reference angle in this case must be supplementary, right? Okay. So the reference angle must be 180 degrees minus 135 degrees, which is 45 degrees. Now remember, reference angle should always be less than 90 degrees. Okay, now what happens if the theta is, let's say, 240 degrees? 240 degrees is more than 180, right? But less than 270, so it is in quadrant 3. This is theta here. This is 240 degrees. The reference angle is this guy, right? Okay, now notice that this part here, this is 180 degrees. 180 degrees plus the reference angle should be 240. So the reference angle must be, theta hat must be 240 minus 180 degrees, right? Which is 60 degrees in this case. That's the reference angle. What happens if the theta is in quadrant 4? Let's say theta equals to 330 degrees. 330 degrees, approximately like this here, right? That's 330 degrees. The reference angle is this angle here. Okay. Notice that the theta plus the reference angle, if the theta is in quadrant 4, should add up to 360 degrees. Therefore, the reference angle must be 360 degrees minus the theta. Oops. 30 degrees. So theta equals to 30 degrees. Okay. Now, my suggestion for you is every time you need to compute or find out the reference angle, at least for the first, for this couple days, okay, sketch that first. Sketch that first. Yes, you need to visualize that later on, right? But for you to visualize that, try to write it, sketch that on paper first. Okay. Now, in general, we see that from here we see that see that if theta is in quadrant 1, which means it's already an acute angle, then the reference angle of that theta must be the same to that angle. It's already an acute angle, right? Now, if the angle theta is in quadrant 2 instead, which means theta is between 90 degrees to 180 degrees, less than 180, right? Okay, then the reference angle will be the supplement, 180 degrees minus theta. Okay, now if the angle theta is in quadrant 3, which means it is between 180 to 270, then the reference angle will be that angle theta, which is already more than 180 degrees, minus 180 degrees. Okay, now finally, if angle theta is in quadrant 4, which means the theta is between 270 degrees to 360 degrees, then the reference angle must be the angle that adds up to 360 degrees. Okay, memorize this. My best suggestion, actually, memorize the picture. Memorize this picture. Okay, memorize this picture. If theta is in quadrant 1, if theta is in quadrant 2, if theta is in quadrant 3, if theta is in quadrant 4. Okay, now what the picture of that theta look like, and therefore what's the reference angle. Okay, now reference angle will be used a lot from this point on, so I need you to memorize this. Okay, I need you to memorize this. Again, memorize the picture instead. Okay, eventually you will get used to it. Now, why do we need to study this? Because we have what our textbook called reference angle theorem. Reference angle theorem, which says the following. Let theta be a trig function, a trigonometric function, either sine, cosine, tangent, cosecant, secant, cotangent, trig function of angle theta, then the trig function of the reference angle must be the absolute value of the trig function of that theta. Okay. In other words, maybe I say it this way. Maybe I say it this way. Okay. The trig function of angle theta is equal to the plus or minus of the same trig function of the reference angle. Okay. Or if I say it another way, in other words, the value of the trig function of angle theta is equal to, I think I should say, is either equal to equal to or opposite of the centric function of the reference angle. Okay, now instead of proving this in words, let's take a look at the following picture. Suppose, for example, we have this coordinate system. Try to make it big enough. Okay, and we have a circle with radius r. So this is circle with radius r. Okay, now let's pick a point on this circle. Let's say I pick this point here. Let's say I pick this point here. So notice that if I pick this point and this is the coordinate x comma y, now take a look at the reference angle. Take a look at the reference angle. This is angle. Let's say this is theta here, okay, which is the same to theta hat, right? Okay, if it is in quadrant 1. Now, I want you to observe the following, the new stuff, fun stuff, good stuff. I want you to observe the following. Notice that the following 4 coordinates in this rectangle here have the same reference angle. Now, the angles are different. The angles are different, but they all have the same reference angle. Now, take a look at this one here. Okay, let's call this theta 2. Let's call this theta 2. Okay, just naming it. Okay, naming it theta 2 to distinguish that from theta that we used earlier. Okay, now this angle theta 2 here has the same reference angle theta hat. You see that? Okay. The opening here, how big this guy here is the same to how big it is. Okay, so they have the same reference angle. Okay. The angles are different. Theta is in quadrant 1, theta 2 is in quadrant 2, right? Okay, but both of them have the same reference angle theta hat. Now, at the same time, if this is x comma y, then the coordinate here must be having the same y, right? But different x. It must be the opposite of x, right? Okay, so the coordinate here must be negative x comma y. I hope you can follow me so far. Now, take a look on, go back to definition 1 of our trig functions. Suppose we talk about sine theta, the one in quadrant 1, sine theta is y over r. Cosine theta is x over r. Tangent theta is y over x, right? And notice that because in quadrant 1, x and y are positives, right? Okay, then all this sine, cosine, tangent must be positive if theta is in quadrant 1. Now, if we switch our view to theta 2, sine of theta 2, according to our picture here, is the y component over the r, right? Notice that when theta is in quadrant 2, theta 2 here, the sine value is exactly the same to its reference angle theta. Okay, however, cosine of theta 2, if theta is in quadrant 2, if the angle is in quadrant 2, the cosine of that is negative x over r. Now, compare this guy here with this guy here. Notice that they are exactly in value except they are opposite. Okay, they are the exact opposite of each other. Okay, but the value is still the same though. I mean, the number wise, they have the same number. They have the same number. Okay, it's just that because cosine theta 2 is in quadrant 2, if the angle is in quadrant 2, cosine will be negative. Okay, but the number will be the same to the reference angle in quadrant 1. Okay, let's observe tangent. Tangent of theta 2, that's y over negative x, right? Again, you see that the number is the same. Okay, but because theta in quadrant 2 has negative, the x component is negative, then tangent in quadrant 2 must be negative. Okay. Let's go on. If we take a look at quadrant 3, the reference angle is the same again, right? Okay, this is our theta head. And let's say I use another color. Let's say this is our theta 3. This is our theta 3. Okay, sorry, from positive x-axis. This is our theta 3. Now then, sine of theta 3, according to our theory, is negative y over r, which is the opposite of sine theta. Connect this guy and that guy. They have the same reference angle. One of them in quadrant 1, that's the reference angle, right? But theta 3 is in quadrant 3, right? Notice that they have exactly the same value, y over r, except that sine in quadrant 1 is positive and sine of angle in quadrant 3 is negative. Okay, and we can do this again and again. Now, for example, if we take a look on the cosine, okay, cosine of an angle in quadrant 3 is negative x over r. That is the opposite of the value of cosine of the reference angle. You see, in quadrant 3, cosine is negative. In quadrant 1, actually in quadrant 1, every trig function is positive, right? In quadrant 3, cosine is negative, sine is also negative. Okay. Tangent of angle in quadrant 3, tangent of theta 3 will be negative y over negative x, which simplifies to be y over x. So you see, tangent of angle in quadrant 3 has exactly the same value with the tangent of the reference angle. Exactly the same. If we switch our view to quadrant 4, and the coordinate with the same reference angle in quadrant 4 will be this coordinate here. This is the same x but opposite y with the coordinate xy in quadrant 1. Now, the same thing, sine of theta 4 will be negative y over r, which is the opposite of sine of the reference angle. this guy here is the opposite of sine of the reference angle. Okay, the same number, y over r, but one of them positive, which is in quadrant 1, and the other one in quadrant 4, the sign is negative. Okay, cosine of theta 4, cosine of an angle in quadrant 4 is x over r, which is exactly the same value with the cosine of the reference angle. So cosine is positive in quadrant 4. Tangent of theta 4 is negative y over x, which is the opposite of the tangent in quadrant 1. Okay, now I hope this explains that reference angle theorem. Okay, the sine of the same reference angle, okay, all this theta and theta 2, theta 3, theta 4, all of them have the same reference angle. Okay, now notice that the value must be y over r, except in some cases you need to be aware that it is actually negative. Okay, now notice that sine is positive. All trig function is positive in quadrant 1. In quadrant 2, only sine is positive. Of these 3 primary trig functions, okay, only sine positive in quadrant 2. Quadrant 3, only tangent. Quadrant 4, only cosine. Pictorially, we can say in quadrant 1, all positive. In quadrant 2, only sine positive. Of those 3, okay? Sine, cosine, tangent. In quadrant 2, only sine positive. Quadrant 3, only tangent positive. Quadrant 4, only cosine positive. Okay? Now, how do we use this reference angle theorem then? Let's take a look on some example. I try to follow closely example from our textbook. Okay, so this will be find the exact value. Find the exact value of, in example 2, find the exact value of sine 240 degrees. Now, the way we think will be as the following. You need to first decide, find out 240 is in which quadrant. Okay, now remember the borderline of quadrants are 0 degrees, 90 degrees, 180 degrees, 270 degrees, right? So 240 is in quadrant 3. Is it okay? So 240 is in quadrant 3, and then sine is negative in quadrant 3. Right? Okay, the reason we decide that 240 is in quadrant 3, so that we know the sine function is negative in quadrant 3. And what is the reference angle? The reference angle of 240 degrees is 240 minus 180 degrees. That's 60 degrees. Okay, now that's what we need to do, at least mentally. If I were you, I will write it down. So the next step from here is sine 240 degrees is equal to sine is negative in quadrant 3, right? So that's equal to negative of sine of the reference angle 60 degrees. Okay, how do we know it's negative, Thomas? Because it's in quadrant 3. How do we know the reference angle? Well, because it is in quadrant 3. So you think about in quadrant 3, how to convert the angle to the reference angle. Now, once you are now in negative sine 60 degrees, then it must be negative of, what is sine 60 degrees? Oh, square root of 3 over 2. Now, that's how we show the word. Next, example 3. What is tangent 315 degrees? Then first, you need to find out 315 degrees is in which quadrant? It's more than 270 degrees, right? But less than 360. So that's quadrant 4. Now in quadrant 4, tangent is negative. Now how about the reference angle? In quadrant 4, that's 360 degrees minus 315 degrees. That's 45 degrees. Okay, we basically do this one here. If it is in quadrant 4, you use this to find the reference angle. Okay, we use this picture. Okay, let's go back. Now, then, because tangent, the angle is in quadrant 4, where tangent is negative, that will be negative tangent of the reference angle. That will be negative. Tangent 45 degrees is 1. So tangent 315 degrees is negative 1. Okay. Example 4. What happens if we have, for example, cosecant 300 degrees? Oh, this is cosecant. Let's change it into one of the primary three functions first. Cosecant is the reciprocal of sine. So this is 1 over sine 300 degrees. Right? Okay. Now then, ask ourselves, 300 degrees is in which quadrant? That is in quadrant 4. Now, in quadrant 4, sine is negative. Okay, and the reference angle is 360 degrees minus 300 degrees. Now, the one I mark in blue here, the one I mark in blue and I circle, you don't need to show anymore in your test. Okay, I just show you what happened, what you're supposed to do, at least mentally. Okay, can I just show it anyway in the test, Thomas? Yes, you can, but you don't need to. Okay, in long run, you should be able to do this mentally. Okay, so this is equal to 1 over, I will then substitute sine 300 degrees by negative, because it is in quadrant 4, sine of the reference angle 60 degrees, right? That's 1 over negative radical 3 over 2. The reciprocal of this will be negative 2 over radical 3, which rationalized to be negative 2 radical 3 over 3. Okay, let's put the negative right in the middle instead. Okay, that's for example 4. Yeah, again, so if you need to compute the trig function of an angle, what we need to do first is find which quadrant that angle located. And in that quadrant, is the function positive or negative of the reference angle? Okay. Now, example 6 and on, we go backwards. I'm sorry. Example 5. Example 5. Let me write it here. Example 5. I happen to skip this one. How about cosine 495 degrees? Oh, this is more than 360 degrees, right? So the coterminal, you subtract by 360 degrees. So 495 degrees is coterminal to 135 degrees, right? So cosine 495 is equal to cosine 135 degrees. Now then from here you see, oh, okay, 135 degrees is in quadrant 2. In quadrant 2, cosine is negative. The reference angle is 180 degrees minus 135 degrees. That's 45 degrees. So continue from that work. cosine 135 degrees is equal to, let's circle this so that you don't confuse that, is equal to quadrant 2. So it's negative of cosine of the reference angle 45 degrees, which is equal to negative radical 2 over 2. Okay, so if it is not between 0 to 360 degrees, then you look for the coterminal angle first. Okay, look for the coterminal angle first. Now, example 6, we go backward. Suppose we know the trig value instead. Excuse me. So suppose sine theta equals to negative 0.5592 and theta is in quadrant 3. Find theta. Now we need to use calculator here. Okay, but if you use calculator, you may not get the right answer, because remember when we do sine inverse, right? The number has to be a positive number. The angle has to be an acute angle. I hope you remember that. Okay, now the acute angle that we get when we use sine inverse or any trig inverse, the acute angle we get is actually the reference angle. So let's do this first. Okay, solution. Since sine theta equals to this number, then sine of the reference angle must be positive number with the same numerical value, right? Now, and remember, reference angle must be an acute angle. So we can use now theta hat equals to sine inverse of this 0.5592. Okay, now get your calculator and then compute what is sine inverse of 0.5592. What I get here is 34.00049 degrees. Right? Okay, but this is the reference angle of theta, which is in quadrant 3. Okay, so this is our theta. This is our angle. Okay, the reference angle, the theta hat, is 34.00049 degrees. Then what will the angle be? Now the angle theta, therefore, must be 180 degrees plus that 34 something. Okay, the angle theta is this guy here, which is 180 degrees plus this theta hat, right? Okay, that's our theta. Okay, so this will be theta equals to 214.00049 degrees. Okay. Now you can try using your calculator. What happens if you do sine inverse of negative 0.55492 right away? No, you will not get that number. In fact, you will get negative 34 something. Okay, there are problems, two problems at least with this answer. First, we have not learned negative angle, what it means, right? Okay, but that's not the only reason. You will see later on, negative angle, negative 34 is located in quadrant 4, not in quadrant 3. Okay, so here's the warning. When you do sine inverse or cosine inverse or tangent inverse, you need to deal with that using reference angle, using an acute angle. Okay, then after you get the angle, you bring it back to, in this case, quadrant 3. Okay, that's question number 6. Let's go on. Example 7. tangent theta equals to negative 0.8541. Well, the theta is in quadrant 4 of this. If that's our tangent theta, in this case happen to be negative, even if it is positive though, but because it is in quadrant 4, we need to look at the reference angle. Okay, the reference tangent of the reference angle has to be the positive value of that number. Okay, and the theta hat is an acute angle, so we can safely do tangent inverse. Okay, using our calculator, tangent inverse of 0.8541, I get 40.50064 degrees. Okay, now you go back to the picture, imagine an angle in quadrant 4. Okay, whose reference angle is that 40.5 degrees something. Now, then what is angle theta? What is angle theta? Our theta is 360 degrees minus theta hat, right? Because theta, the one in green, plus theta hat, the one in red, supposed to add up to 360 degrees. So the theta that we're looking for is 360 degrees minus the reference angle. That is theta equals to 319.49936 degrees. Okay. Let's go on. Example 8. I do like many examples here, but the underlying concepts are actually exactly the same. Now, sine theta equals to negative 1/2. Oh, that's a special value, right? So the angle must be a special angle. Okay. However, theta is in quadrant 3. So let's see how we're supposed to think. Okay, sine theta is negative number, negative 1/2. So sine of the reference angle is positive 1/2. But this is an acute angle of special angle, right? Okay, so you can just say right away, or sine what in quadrant 1, sine what in quadrant 1, or sine what of an acute angle is 1/2. Oh, we know it's 30 degrees, right? Now bring this back to quadrant 3. We already know the reference angle. Okay. So the reference angle is 30 degrees here. So what will the theta be? 180 degrees plus theta hat. So theta equals to 200. Okay. Now this example 6, 7, 8, we talk about primary trig function, sine, tangent, sine again. In example 8, we have exact special value, right? Now, what happens if we deal with, for example, secant, cosecant, cotangent? Let's say example 9, we have secant theta equals to 3.8637, where the theta is in quadrant 4. Okay. Always deal with the reference angle first. Okay, so secant theta equals to 3.8637, right? Okay, that implies secant theta hat must be the positive number of that value. But that value already positive, so we just keep it that way, right? Okay. Now then, from here, we take a look on the reciprocal. Okay. So secant theta is reciprocal of cosine theta, the reciprocal, right? So we do the reciprocal here. So secant is reciprocal of cosine. So if secant is blah, then cosine must be 1 over blah, right? Now then, because this is already a reference angle, we can safely do cosine inverse of that number. Use your calculator to find the reference angle. Cosine inverse of 1 over 3.8637. I get 74.99999 degrees. Okay, that's the angle. Now we bring it back to quadrant 4. Okay, so if this is our coordinate system, and it is in quadrant 4 with reference angle almost 75 degrees, then what will the theta be? 60 degrees, right? So 360 degrees minus 74.99999 degrees, that will be 285.00001 degrees. I believe our textbook will just call this 285 degrees. Okay? But in my class, round to 5 decimal places. Okay, so again, if you deal with secant, cosecant, cotangent, which is secondary trig values, convert that to the primary first. Last example, example 10. What if we have cotangent theta equals to negative 1.6003, and our theta is in quadrant 2. Find theta. Well, cotangent theta equals to that number. So the cotangent of the reference angle must be the same number but positive. Okay. Now, cotangent of that reference angle is the reciprocal of tangent of the same reference angle. But if I do reciprocal on the left-hand side, I also do reciprocal on the right-hand side. Okay, so the reference angle, which is again already an acute angle, is tangent inverse of 1 over 1.6003, which will be tangent inverse of 1 over 1.6003. That is 32 degrees something, 32.00056 degrees. But this is in quadrant 2. Okay, so try to picture that you have an angle in quadrant 2 whose reference angle is 32.00056 degrees. Then what will the theta be in standard position? Well, theta will be 180 degrees minus that reference angle. Okay, that gives me 147.9994. Okay, that's our section 3.1. Your suggested homework here, section 3.1. I would like you to do number 1 to number 79. Okay. Now, when you do your homework, okay, please take note. This is very important. Take note. Not only for my class, but this is actually a tradition. If theta hat is a special angle, then your answer should be in exact form. Okay. Actually, if the trig value is a special value, then the angle should be a special angle. Okay, like the one we have here, the sine theta equals to -1/2. You see the sine, then sine theta hat is 1/2. That 1/2 is a special value for sine, right? So the theta hat must be a special angle. Okay, then don't use calculator for that. I mean, yeah, you can use calculator and get that 30 degrees, but why? You should have memorized that, right? Okay, now that's for this section 3.1. I know that's a long section here, but please study as much as you can. Okay, we will go on to section 3.2. Section 3.2. Almost not related to what we had in 3.1. Of course, toward the end, you will see some relation, but you can actually study 3.1, then 3.2. You can also study 3.2 first, and then 3.1. Okay, in this 3.2, we learn a new measure for angles. It's radians and degrees. Okay. Beside degree measure, an angle can also be expressed in radian measure. Okay, now in fact, we will talk about radian measures a lot for the next couple chapters. Okay, but especially once you are in calculus, then almost all the angles will be expressed in radian measure. You will see toward the end of this section, I think 3.4 and 3.5, we use the idea of these radians here to compute, let's say, the arc length or the sector area of a circle. Okay, and to compute those, we need the angle to be expressed in radian measure. Okay, so right now we learn about what is radian measure first. Definition. Okay, in a circle, a central angle that cuts off an arc equal in length to the radius has a measure of 1 radian. Okay, so suppose I have a circle. Let's say I have a circle, and the radius of that circle is r. Now, if the central angle cuts the arc, let's say this is central angle theta, and the arc, the length of the arc here, is the same to the radius, which is r, then the theta is, that's how we define the theta to be 1 radian. Okay, that's 1 radian. Basically, you will see radian is actually the ratio of the arc length cut off by the central angle to the radius of the same circle. Okay. Let's write it. So if the central angle theta cuts off an arc of length s, then that angle in radian is defined to be s over r radian. Okay, pictorially, suppose I have that circle again. Let me make it a bit bigger now. Okay, and then this is the radius. Radius r. Okay, and then the angle actually sweeps through or cuts off. Let's say this is the angle theta here, such that the length of the arc, let me use this one, the length of the arc is s. Okay, then that angle theta is equal to the arc length subtended by that divided by the radius r. Okay, it's just that simple. It is just that simple. Okay. Let's do a very short example. Very short example. Suppose the arc length cut off by the central angle is 6 centimeter, and the radius r is, let's say, 2.5 centimeter. Okay, then what is the central angle in radian? The central angle in radian will be 6 centimeter over 2.5 centimeter. Okay, which will give us 2.4 radian. I think I should say radians. Okay. Now, some note, and this is a very important note, by the way. Note, because besides teaching you the trick, I need to also teach you the tradition behind the trigonometry. Okay. Now, since radian measure is actually a ratio to be more precise, the ratio of arc length to radius length. Both of them lengths, right? Then radian measure is unitless. If we go back to this example here, notice that the centimeter cancel a centimeter, right? So 6 divided by 2.5, it's simply 2.4, and that's it. Okay, we call that radians, right? But even if we don't write the radians, it's still understood as angle in radian. Okay, so let's write it explicitly. So the 2.4 radians that we have earlier, radians, we also usually write that as 2.4 rad, right? That's again for radian, okay? Can be written as theta equals to 2.4 only. Okay, you don't need to write the radians anymore. You can just write theta equals 2.4, and it is understood that it is in radian. Okay. Furthermore, okay, an angle written without degree sign must be in radian. If you don't write the degree sign, it means it is in radian. Okay. With that said, let me write you this big warning. From now on, you need to be aware that, for example, when we write 30 degrees, this is not the same to 30. Okay, because if you don't write the degree sign, then it must be in radian. If it is in radian, it means, like, for example, this 30 without degrees, right? Means the arc length is 30 times the radius. Okay, that's a very big angle. It's more than one cycle. Okay, 30 degrees is less than 90 degrees, right? Less than the right angle. That's an acute angle now. 30 radian is very big. Okay, as you know, that one cycle, right? One cycle is only 2 pi r, right? Okay, so actually implicitly, I'm teaching you something new here. If one circle is, the circumference of a circle is 2 pi r, circumference of a circle, then what is the central angle in radian? Central angle in radian will be 2 pi r over the radius. That's 2 pi. Okay. That brings us to a new topic, but let me write it down properly. Let me write it down properly. Okay. Conversion. It starts from one full circle. One full circle corresponds to 360 degrees. I think I should call that one full rotation, huh? One full rotation is 360 degrees. But at the same time, the circumference of a circle with radius r is 2 pi r. That's the arc length, right? So you will see the 360 degrees that we have for 1/4 rotation in radian is actually corresponds to the arc length divided by the radius r, which is 2 pi. 360 degrees corresponds to 2 pi radian. 180 degrees corresponds to pi radian. Okay. Now try to picture this. Try to picture this. For our special angles, if 180 degrees, which is a straight line, a straight angle, is pi, then the 90 degrees must be pi over 2, right? Try to picture that. That's half of 180 degrees, right? Okay. And 60 degrees is 180 divided by 3. That's pi over 3. 45 degrees is 90 degrees divided by 2. So that's basically 180 degrees, which is pi divided by 4. 30 degrees is 180 degrees divided by 6. Okay, pi over 6. Please memorize this. This shows up a lot. These special angles actually shows up a lot. Okay, the faster, the earlier you memorize this, the better you will be. Okay. So, oh, by the way, what is 0 degrees? 0 degrees is 0 radian. Okay. Now, how do we do conversion then? Once we know these, especially this one here, then we will do the conversion in the following way. Okay. To convert degree to radian, what we do is we will multiply by pi over 180 degrees. So divide by 180 degrees to cancel the degrees, then multiply by pi. Okay. Now, if we convert from radian to degree, we cancel the radian first, dividing by pi, multiply by 180 degrees. Okay, now let's do some example. I hope these examples are actually quite simple. Example 2, what is 45 degrees in radians? Now we know earlier up there, we already know up here that 45 degrees is pi over 4, right? Okay, but suppose we use this formula, then it will be 45 degrees times pi over 180 degrees. Now you see the degrees cancels, right? Okay, and 45 is 1/4 of 180. 180 is 4 times 45. Okay, so I can cancel this further. This is 1, this is 4. So 45 degrees is equal to pi over 4. Okay, example 3. How about 450 degrees? The same thing. 450 degrees times pi over 180 degrees, right? The degrees cancels. Actually, the zeros also cancels, right? 45 and 18, both of them multiple of 9. 45 divided by 9 is 5. 18 divided by 9 is 2. So this is equal to 5 pi over 2. How about converting from radian to degrees. Let's say if I have pi over 6. Well, multiply that by 180 degrees over pi. I'm sorry, it should be pi over 6. Okay, now the pi cancels, right? And 180 divided by 6 is 30 degrees. Example 5. How about 4 pi over 3? What's that in degrees? 4 pi over 3 times 180 degrees over pi. Pi cancels. Actually, 180 divided by 3 is 60. Right? Let me show that. This guy and this guy, this is 1. This is 60 degrees. Right? So then 4 times 60 degrees, that's 240 degrees. Okay. Example 6. Then how do we compute, for example, sine pi over 6? Now we know pi over 6 is 30 degrees. Now try your best from now on to think from radian point of view. Okay, you can write it this way, of course. So pi over 6 is 30 degrees. And sine 30 degrees is 1/2. Okay, in some sense, you convert that to degrees first. Okay, but I want you to train yourself not to do so. Okay, train yourself to imagine the special angles, especially if you have special angles when you have other quadrant. For example, how about cosine 7 pi over 6? Now notice that the quadrant system. Use another color. Now we know the boundaries for the quadrant system is 0 degrees, 90 degrees, 180 degrees, 270 degrees. Those are in degrees. What are the boundaries in radian? In radian, this is 0 radian. This is pi over 2. This is pi. So 7 pi over 6 is more than pi, right? But less than 3 pi over 2. Okay, so we know that 7 pi over 6 is in quadrant 3, right? 7 pi over 6 is in quadrant 3. Okay, because it is in quadrant 3, cosine is negative. Then what is the reference angle? Well, 7 pi over 6 minus pi give us pi over 6. Okay, that's the reference angle. Okay, and cosine pi over 6, which is cosine 30 degrees, is radical 3. Okay. Try your best not to convert that to degrees. Try your best to think in radian. I know it's not easy. I never say it will be easy. Okay. But the earlier you can memorize this conversion, okay, in radian from quadrant 1, I mean quadrant 2 to quadrant 1, quadrant 3 to quadrant 1, finding the reference angle, the faster, the better you will be. Okay. Last example, let me do it here. Example 8. Suppose I have 3 cosine of 2x plus pi over 2. And x is actually equals to pi over 3. Let's do this. Function So I plug in numbers. 3 cosine of 2 times pi over 3 plus pi over 2. That is 3 cosine of 2 pi over 3 plus pi over 2. LCD 6. This is 4 pi plus 3 pi. That's 3 cosine 7 pi over 6. Oh, we did that earlier. Oh, yeah, that's example 7. Okay, so this is equals to 3 times 7 pi over 6 is quadrant 3. So cosine is negative. The reference angle is pi over 6. Okay, so this is 3 times negative radical 3 over 2. That is negative 3 radical 3. Okay, that's how we compute it. Your suggested homework for the section 3.2 will be number 1 to number 7. I think that one is easy. That one is just further. I don't know. Take a look at 11 to 21 and then 31 to 63. Okay, that's the suggested homework. Okay, that's for our lecture 4. From here, once you're done watching this lecture video, okay, you may want to repeat your notes, read your notes again, and then after that, take a look on my supplemental lecture video if available. Okay, so long.